Hello. Let's start with a lecture here on measures of central tendency. So this will be kind of a part of a three-part lecture here. We'll talk about central tendency. We'll talk about variation. We'll talk about some other things like that. But we're going to start off here talking about this idea of central tendency, and that's a phrase that sounds a little weird at first. It's not a commonly heard phrase. But when we say central tendency, it's just kind of it's just a different way of saying the word middle. And so if I have a set of data, so I've got a bunch of, let's just say numbers that I'm dealing with, then I might be able to say, all right, let's try and figure out from this set of data, let's figure out some concept of the middle of that data. It would be wonderful if we could state a single number that represents what's in the middle of that data. Something very natural might be, hey, let's just say I had 1, 2, 3, 4, and 5. Well, some concept of the middle of that, you might say 3. And that's a very simple example there. So there's going to be four types of measures that we'll talk about, four different things that we can use to measure this idea of the middle of central tendency. Three are very common: mean, median, and mode. You've probably heard of those before. And then the fourth will be mid-range, and we'll talk about that at the end. So let's start off with mean. Another word for mean is going to be average. Mean is just a little bit more formal. And so we're going to denote the mean by capital X bar. So with it, we'll put a bar over a capital X, and that denotes the average, the mean. And so that's the mean of a data set, X bar, and it's just the average of all the values. So mathematically, how we could write this is you could say, I'm going to take all of the data points and I'm going to add them up. And you'll notice I'm using similar notation to what we've seen before, where I'll have dot, dot, dots, and then I'll say xn. So basically, we're just saying, hey, I just take all of my data points and I add them up, and then I divide them by the number of data points that I have. And we've seen this summation notation before. This sum means add them all up, and this is a sigma. So that sigma means add them all up. And when I say x sub I, that's just saying, hey, each of them, let I just change. Let it be 1, then let it be 2, and then let it be 3. And so it's sort of an indexing. It's sort of just a numbering of each of our data points. And so then we divide by the number of data points that we have, n. So this down here is just a fancy formulaic way of saying take an average. Taking an average should be something that's fairly straightforward. So if all of this seems confusing, don't worry about it. It's just take an average, and that's what the mean is. So let's go ahead and look at this set of data here, and let's find the mean for this set of data. So we've got 1, 1, 2, 3, 5, 8, 13, 21, and 34. So to take an average here, I'm just going to add all of these up. 1 plus 1 plus 2 plus 3, and so on. And then I want to divide by the number of data points that I have. And so if I count these up, I say 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 data points here. And so we're going to have 88 when we add all those up. 88 divided by 9. You could leave that as your answer. That's a perfectly acceptable format. You could also write it as a decimal, and maybe we could put an approximately. There we go. So it's approximately 9.78. That's our mean right there. Nice and simple there. Just taking an average of all of the data that we have. Now let's move on from mean to median, and with median, it's kind of a roundabout way of explaining this, because we talk about median being a way to talk about the middle of the data. We talk about it being a way to measure the central tendency. But for sort of an informal way of defining the median, it actually is the middle value. And so what I mean by that is we're going to take our data and we're going to order it from smallest to largest. That's going to be very important here. You want to make sure your data increases from left to right. So you're going to list out your data. You're going to basically sort your data. And then what you're going to do is you're just going to start crossing out the end values. And then now that you've crossed those out, now you just have a new smaller set of data where you've crossed out the largest and smallest. So now you're just going to keep crossing out the values on the end until you reach the middle. And whatever number you get in the middle is exactly your median. So if we're looking here, what we're going to do is we're going to take this data here and we're just going to start crossing out. Hey, let's cross out the outside. All right, now let's cross out the outside. Then let's cross out the outside, and we're left with just that 5 right in the middle. And you can kind of look at this. You could look here and you could say, hey, this kind of looks like it's right in the middle anyways. You know, there's 4 numbers on this side of it and 4 numbers on that side of it. And that actually is exactly what we're going for. We're going for that number that is located in the middle there, 5. So to kind of show this in a little bit different light, sort of step by step, I've listed the data right here up at the top, and then I've crossed out the numbers on the side. So then what I do is I say, all right, now I have just these numbers here. And so let's cross out those end numbers. And now I just have 2, 3, 5, 8, and 13. So then write that 2, 3, 5, 8, and 13, cross out the end. I now have 3, 5, 8, and then I have my 5 right there. And that's my median. That 5 is the middle point of the data. It's the data value that is right in the middle if I just start crossing off endpoints there. So let's go ahead and let's do one more example. I'm going to slightly edit this, and you'll notice I've removed that 34 data point there. And so if we go ahead and we do this, so we're going to write out that data. We're going to cross out the ones on the end. And then at that point, we rewrite what we have. We have 2, 3, 5, and 8 after we've crossed out the new endpoints, the 1 and 13. So next I'm going to cross out the 2 and the 8. And now I have 3 and 5. And the question here is I have 3 and 5. If I cross both of these out, now I don't have any more data points. I've just crossed out all my data points. So the question here is, what the heck do we do? Well, what we have to do is when we end up with an even number here, when we end up with two remaining values and crossing them out won't do us any good, we have to take the average of them. And so you'll notice that whenever you have an even number of data points, here I have 1, 2, 3, 4, 5, 6, 7, 8. An even number of data points will end up with you having a 2. You'll have 2 data points left as you cross out the ends. And so that means that you need to take an average of these. So in this case, we would say that our median is 4. We would take an average of 3 and 5. So right in the average there, 3 plus 5 would be 8, divided by 2 would give me 4. And so 4 would be our median. Let's go ahead and write that right there. 4 is equal to median. Great. And so odd number of data points versus an even number of data points, a slight difference in how we find that median, but it's still, in both regards, it's still crossing out the ends here. And then if you have an even number, then you're going to end up with 2. So you got to take an average. If you have an odd number, you'll just end up with 1. And that's your median right there. Great. Let's move on to mode. And the mode is quite a bit different from the mean or the median. So the mode of a data set is the value or multiple values that occur the most often. And so let's take a look at this same data set here. So we've got the same exact data set that we just dealt with. And here, I noticed that 1 appears twice, and everything else just appears a single time. So this 1 appears more often than every other data point, than every other data value. And so we're going to say that that 1 is the mode. And there we go right there. So let's do another example here. It's going to look very similar, but you'll notice I've added an extra 21 here. And now I have 2 1s and I also have 2 21s. In this case, we actually say, oh, and then I also have 2 5s here. I missed that. So I've got 2 1s, 2 5s, and 2 21s. So what we're going to say is that the mode is actually all of them. We actually would have multiple modes. We'd say 1, we'd say 5, and we'd say 21. You could contrast this with a data set where maybe I give you a data set that looks like 1, 2, 3, 5, 8, 13, 21. In this scenario, none of them repeat. And so we'd actually just say there is no mode. And in this case, everything just appears exactly once. And so there would be no mode. I could give you another data set. I could give you something like 1, 1, 2, 2, 5, and 5. And there, each thing appears 3 times. Or excuse me, each of the 3 things appear twice. And so we would say, again, that there is no mode there. Now, what we'll notice here is that in these data sets and these examples that we've been dealing with, they were sorted beforehand. For the mean, that doesn't really matter a whole lot. It doesn't really help us because with the mean, we're just adding things together. And so having them sorted isn't really important. But for the median and the mode, having things sorted is very helpful. For the median, obviously, because we need to cross out the endpoints of our data, the largest and the smallest. So having it sorted is key there. And so if your data isn't sorted, you want to sort it on the first step. Mode, it's helpful as well to sort your data because then you can just very easily see the repeats. It might be tough to see how many repeats you have if your data isn't sorted. So it's always a good idea when you are given a data set to start off by sorting it. Let's finish up with the mid-range. So the mid-range of a data set, it's going to be the average of just the lowest and highest values of the data. So you're just going to take the smallest and the largest values and you're just going to average them. So if I add those together and then I divide by 2, that's just taking an average of those 2 points, and that gives me the mid-range. So with this data set here, I could say that the mid-range is the average of the smallest and the largest data set. So 35 over 2. 35 over 2 would be an acceptable answer. You could also write 17.5, and that would be our mid-range right there. Now, I want to talk about sort of these measures of central tendency. We've seen mean, median, and mode and mid-range. And I want to talk about when they're useful and when they're not. And so if we look at this, the mean is one of the most useful things that you can talk about for a data set. It tells you right what the average is. You hear people talk about that a lot. Maybe for exam scores, you say, hey, the average was this, the mean was this. And this is useful as long as you don't have a bunch of outliers in your data. So maybe we're looking at exam scores and maybe there was one person who got 100% on the exam, but then the next highest score was an 85, and then it sort of trickled down from there. The mean in that scenario wouldn't be that useful because that single high score, that outlier, that really, really large 100% as opposed to the rest of the scores, that's going to skew that mean towards that sort of inappropriately, if you will. If you just have a single person, maybe we could do the contrast of this, the opposite. Let's say you have a single person in a class get a 0 on the exam because they didn't take it. Well, if I have all of my students taking the exam and getting around a 70 to 80 and something like that, but then one student gets a 0, when I add that in, that's really going to affect that average. I would encourage you to try this out. Write down a bunch of data points, and then maybe 10 or so, and then add in an outlier that's crazy. Add in something that's just so different from the rest of those data points, and calculate the mean in each of those scenarios. And I guarantee you'll notice the difference between them. So the mean is useful most of the time, but if you have outliers, it can be a little bit skewed. It can be a little bit misleading. The median is generally always useful. Most of the time, the mean and the median are very similar. If the mean does not help you because of outliers, that's where the median can help. Because you'll notice that the median doesn't care how large those outliers are. If we're just crossing out the points on the end, then it's just going to cross them out regardless of how big they are. The mode is pretty particular in when it's useful. It's useful if you want to know which data point occurs the most frequently. If we're looking at something like exam scores, it doesn't really help me to know that 77 was the most common grade on the exam. That doesn't really help me at all, just because the exam is so the exam points are so distributed, from 0 to 100, that knowing that 2 people got a 77 and everybody else had their own individual grade, that doesn't really help me. But if I'm doing something where maybe I'm surveying people on their favorite color, now mode is helpful because mode tells me which color appeared most often. And so that's a point, a scenario where mode would be helpful. The mid-range, I think it's fairly useless. There's not very many scenarios in which the mid-range is helpful. Sometimes it is. There are cases where it's helpful to know what the mid-range is, but most of the time, mean, median, and mode are really the 3 that help you the most. And obviously, writing all 4 of these down for a data set is great. Having all 4 of them is very helpful. Seeing the slight differences between the mean, median, mode, and mid-range can be very useful for a data set. All right, let's finish off with one more example. And here we're going to talk about grouped mean. So we've seen this data set before. We've seen the highest recorded temperature in each state, in all 50 states in the United States. And so here we could find an average of this. We could take all 50 of these, we could add them all up, and we could divide by 50, the number of data points that we have. But I'm going to be honest, that sounds like a lot of work. That sounds pretty tedious. I don't want to manually add all of these 50 together. That's going to be a lot of work. So what we could do is we could go back to our frequency distribution. And we could recall this frequency distribution that we've made here, where we group the temperatures into intervals. So like 100 to 104 and 105 to 109 and so on. And then we mark the frequency of how often temperatures occur in those ranges. Well, what we can do here is we can say, hey, let's take a look at the average, the middle of each of these ranges. And you'll notice that it's kind of just shifting by 5 here, but I'm looking in the middle of 120 to 124. The number right in the middle there is 122. The number right in the middle here is 127. The number right in the middle here is 132. And what I can do, this isn't perfect, but it's a lot faster, is I could pretend as though there were 3 102s. Obviously, that's not exactly the case. There are 3 data points that are in the range of 100 to 104. But if I just pretend that instead of them ranging between 100 and 104, if I just pretend that they're all 102, that's a lot simpler to deal with, because now I just have one number that just repeats 3 times, and I can deal with that. And then likewise, instead of worrying about all 16 of them between 110 and 114, I can just pretend that all 16 of those have a value of 112, and that's a lot easier to deal with. So when we work this out, let me go ahead and copy this. So you'll notice here that I've got my 102 that occurs 3 times. And so in just a slightly more succinct way of writing 102 plus 102 plus 102, I just write 102 times 3. That's just a lot simpler to deal with. Then I take my 107 and I do 107 times 8, and I'm adding all those up. So I'm adding 3 102s. I'm adding 8 107s. Within this dot, 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 I'm adding 16 112s. I'm adding 13 117s. I'm adding 7 122s. And then I add my 2 127s. And then I add my 1 132. And what I'm then going to do is I'm going to divide by 50. And you'll notice I've written this 50 for those 50 states a little bit differently. I've written it as a sum of all of these, but it is 50. And you get 114.3 right there. This is what we're going to call grouped mean. It is not the exact mean here. It doesn't perfectly work out there. in this case. This is not the exact true mean, but it is an approximation. And actually, we could maybe do that. We could say, hey, it's approximately this. So this is an approximation. It's not exact, but it's a lot faster to deal with than actually counting up all of those individual 50 states. It's a lot faster. I don't remember off the top of my head exactly what the actual mean is, but I would encourage you to do that. Come on back to this page right here and actually take the average of all of these, add all 50 of these up, and divide by 50, and you'll actually get something very close to 114.3. I forget exactly what it is off the top of my head, but it is close. And so that kind of shows the effectiveness of this grouped mean method here, and how good it actually can be at getting you a rough sense of your average there. So that's going to be the measures of central tendency. We've got mean, grouped mean as well, median, mode, and mid-range, and we've talked about when those are each useful, and we'll go ahead and call that the lecture.